Now let's look at what the requirements are for this week. And I'm going to pull up the course syllabus and see exactly what's your requirement for this week. And as you can see, the topics and assignments for this week is reading Chapter 6 from the textbook. I anticipate each and every one of you to go through this chapter, read it fully, understand it. You can even have discussions about it through the team forum. It wouldn't hurt to ask questions to your other teammates for clarifications and answers. You can ask me through the general discussion, or you can also email me. But I prefer the general discussion forum so others can benefit from answers as well. Once you read the chapter 6, then there will be a discussion around Six Sigma project selection methods. If you go to the discussion forum, you'll be able to see what's required for this week's discussion, and there's a file for reading on Six Sigma project selection methods. And once you read the file, make sure you answer all the questions required in the discussion forum. The initial post is due on Thursday, 11:59 p.m. Eastern Time, and the 2 response posts are due by Sunday, 11:59 p.m. Eastern Time. I always recommend my students to go and post their responses ahead of time in order to ensure that the discussion forum is enriched with engagement, a lot of participation, good thought sharing, and idea sharing, which really foster a lot of collaboration between all of you, and to find this course very interesting and very exciting. I'm sure all of you have experiences to share, examples, links, videos, games, things of this nature that are relevant and pertinent to the discussion on hand, as well as the Chapter 6. So make sure you drive some creativity as you respond to your other classmates. And also you could include that during your initial post. Don't wait until the last minute to do so. So the article is accessible by clicking this link. Now, after the discussion, there is a team forum assignment, which is about define phase and project scope. Okay, so let us look into that here very quick. Module 2. We know that Module 2, when we look at the define phase, we are particularly looking at these tools: project charter, which consists of the problem statement, project scope, and project goals. Along with that, there is the affinity diagram, critical to quality tree, and some more. Okay? These are some other ones that are part of the define. So we already talked about the project charter. And the VOC is also part of the define phase, which is capturing voice of the customer. Mapping the process is another piece that is part of the define phase. The stakeholder analysis and SIPOC. And SIPOC stands for Supplier Input Process Output Customer. These are the main elements of the define phase. There are some others. As you could see, the affinity diagram is one of them. Some tend to put the affinity as part of the measure phase. Some others put it as part of the define phase. So right now, we're just going to assume that it's part of the define phase. That's been instructed to you. And the goal is for you to become very familiar with these tools. They're very important. And you want to make sure that you have a robust define phase before you move on to the other phases. The other things that you will be exposed to that this module covers is the PDCA. In the previous week, last week, you covered DMake and DMADV, and the discussions around this were magnificent. I really enjoyed what I read from all of you. So I would like to congratulate you for the great work that you guys done through the discussion forum. So now it's more about the PDCA. And also with the Plan, Do, Check, Act or Plan, Do, Study Act, or the Deming wheel, whichever you call it, this is another problem-solving methodology. And this is the heart of continuous improvement. The term continuous improvement truly evolved out of this concept of PDCA, as it's a continuous wheel that is never ending. Philosophically, it evolves based on the evolutionary change has an infinite path towards the ideal state. So think of that as you implement the PDCA. Also, you'll be introduced to the work breakdown structure and some others as you will learn from the article around the project selection methods in Six Sigma methodology and so on and so forth. I suggest from all of you to read this module overview, which in fact talks about the PDCA and covers the critical to quality as well as the project selection methods in Six Sigma and the key steps in the define phase. Read this article, become familiar with this article, and then move on to the module resources. And there are 4 articles that we'll touch base on here in a second. And afterwards, we've already talked about this piece, and the team forum will cover this more in details. Then there is a quiz. At the end of the week, there is a quiz that you need to take that reflects your understanding and your proficiency with the materials that were covered last week and this week. I think all of you should ace this one. It's really based on definitions. Once you click this link, you'll be able to access the quiz. Be as very explicit and descriptive as you can. Provide details. The more I read of what you understand about these concepts and ideologies and methodologies, the better the grade will be. Then the self-assessment, as you know, this is a non-graded activity, but still there's a project charter, 2 questions involved with this project charter piece. And project charter, as you know, is one of the key components of the define phase. So for you to understand the difference between the project charter in Six Sigma and the traditional project charter in PMI, it's very important that we, touch base on that as well and why it's important and necessary. Okay, I think I explained all the requirements due for this week, the discussion, the team form defined phase and project scope, the week 2, and the self-assessment. These are the main key things. But that's not all of it. It's a great idea to read through these modular resources. There are 4 articles in that folder. There is this article from ASQ.org. Let me close this one out. This is the article in one of the links around Plan, Do, Check, Act. This is why I didn't want to touch base on this and explain it to all of you, because this one is really covers the PDCA in a very fashionable way. Okay? The only thing that I could add to this article is that PDCA, Plan, Do, Check, Act, and SDCA, Standardize, Do, Check, Act, tend to work together. What does that mean? Well, think about it as if you are going up the stairs. If you're going up the stairs, think about each step or each stair is where you have SPCA, Standardized Do, Check, Act. Once you make that jump to the next step or the next stair going up, then you use PDCA. You're setting new benchmarks. You're setting new standards. And once you jump, then you set the new standards again. So you apply the SDCA. In order to jump to the next level, you apply the PDCA. And so on and so forth, working your way toward your ideal state. Does that make sense? So this article is very important to understand. Plan, Do, Check, Act is something that the only drawback with this concept is it doesn't have the tools identified under each phase. For example, if you ask someone what falls under plan or what falls under do, what are all the tools? It's not well structured to show all the tools and techniques that fall under each of these categories. Unlike do, make, each phase has a set of tools within the toolbox that tend to help you and walk you through all the phases in a very structured approach. The other drawback of Plan, Do, Check, Act is that it never ends, and it leads you to new stage of continuous improvement. And that could be cumbersome. That could be tedious, and it could be time-consuming sometimes. While Lean philosophy believes in the subtle, incremental, continuous improvement, it is very important that re-engineering and revolutionary change are important too. So make sure as you do these Plan, Do, Check, Act, you also apply some breakthrough improvements to get you from point A to point Z rather than have to go through the whole alphabet one step at a time. So think about that as your competition might be going and improving and growing faster than you are, while you're still thinking that you're doing improvements. It's so small, it's so incremental that it doesn't get you to the ideal state in a very timely fashion and maybe through some shortcuts. This is why I recommend applying some tools of optimization, simulation, and also Six Sigma and design for Six Sigma, as they tend to help streamline things rather faster, even though the project might last longer than the PDCA. Does that make sense? So that is why PDCA might be a little bit slower in progress than others do. Doesn't mean that you can't have some home runs with the PDCA, but it's just the fact that it lacks the necessary structure around the tools and the toolkit might not lead you to where you want to be in a timely fashion. So enough talk about the Plan, Do, Check, Act, but that's my personal experience with this cycle. So I definitely recommend that instead of sometimes improving the quality of the product on and on and on, maybe think about the redesign of the product, or maybe rationalize the product and do some, either redesign or bring in another product that can cannibalize that product and take over and gain more market share, something of that nature. So that's with the PDCA. I also would like you to read this critical to quality trees. This is an important piece of Six Sigma. Why? Because it goes from a concept that is broad and it takes you to the whys, the measurable variables, things that you can measure. So, for example, you might say we have problem with quality. This is probably a bigger statement. Let me kind of simplify it by sharing this slide with you. This is an example where when we say we would like faster and lower cost products in the market, what does that mean? Well, it means that there are some drivers and there are some CTQs. So the drivers are availability, capacity, and cost in order to achieve this. Now, what does it mean by product availability? Is that the waiting time between stages, testing cycle time, and so on and so forth. The cost means the number of samples, tests, and labor hours. These are the whys of the projects. These are the things that we are able to measure, we are able to set a metric for, and, of course, ensure that we are making a difference by seeing that metric progressing or getting worse. So that countermeasure effect on the Y metric will be clearly identified and monitored versus just looking at this big concept based on the voice of the customer. Does that make sense? And based on the Y from the CTQ, we can then determine the letter X's that impact this Y, for example, the test and labor hours in this case. There are more examples that you will find here. As you read through this statement, you will see how to use the tool, identify critical needs, identify quality drivers, so on and so forth. As you can see here, the need based on the voice of the customer This is good customer service. The customer wants good customer service. Well, what does that mean? What it means is that the quality driver for good customer service is waiting time, pleasant staff, refund policy. So out of these three, see how this is a tree diagram? This is what we call a critical to quality tree. And for the waiting time, we're talking about 90% of customers satisfied with waiting time. All phone calls answered within 20 seconds. You see how specifications, upper and lower specifications, it becomes more critical now that we could build out of this, we can build process capability, control charts, Pareto analysis, so on and so forth. That is why it's good that you do this exercise to understand going from the need into some measurable whys or some measurable output variables. And then from there, you can determine the input variables that affect the output variables. Okay? That is the second article, and I would love for me to read it and take the time to understand it. Next is the project charter. In the project charter, this one really outlines all the different categories in the charter. So read through this. As you'll see, there is business case, objective, scope, assumptions, constraints, so on and so forth. And there is an example here. So that's one example of the project charter. I do have another example for you. And you could see, you could build this in a PowerPoint and have it put together in this fashion. The business case, here's an example of a problem statement. See what we talked about, the 5 W's and 1 H, specific and measurable? This is what we mean by that. Numbers. This is the difference between a problem statement for a Six Sigma versus a problem statement that you see out there outside of the Six Sigma arena. Because this one includes some measurables. Our current reaffirmation rate is 35%. With this impact, the significance of the project is this and that. A 5% improvement would result in this. And this is how much is incurring in expenses, when, how long, all this stuff. Remember, sometimes you can't pick up any projects for a Six Sigma. The Just Do It project should not go through the DMAIC methodology. Just Do It projects, you just go ahead and do it because it's so simple. It's a low-hanging fruit. You don't have to spend 3-6 months working on it, involving a lot of stakeholders and so on and so forth. For example, when you know there is a tooling die that needs to be replaced because of wear and tear, there's no need to generate and run through the DMAIC methodology for you to go ahead and purchase a new one. This is a matter of picking up the phone, call your maintenance department and tell them that die is causing a lot of defects. It needs to be replaced. It's past its preventive maintenance schedule, so on and so forth. So you have to make sure that your Six Sigma project selection is based on certain criteria. And one of them is the impact to the business. Like I mentioned before, some businesses identify the threshold for the Greenbelt Six Sigma project to be at least $100,000. Some others, they determine to be $50,000. So make sure, and for a black belt, at least $250,000. And for master black belt is $1 million and plus. Okay? So think about that. I'm sure it varies by business type and structure and products, so on and so forth. But here's an example of a project charter which lists the business case. And again, business case is really what it does is take this problem statement plus the goal of an objective, and it puts them in a nice business case. So think about that. So taking this category plus this category and putting it in a business case. So what I suggest is you start with the problem statement, of course, your number one, start, and then work your way to the goals and objectives. Make sure you use the concept SMART. Smart, specific, measurable, attainable, realistic, and timely as you build these goals and objectives. You could have one goal or you could have multiple goals. Okay? And the goal also has to use some measurables. I would be skeptical about these goals that I see here. So make your goal stated in a way that says from this to this, eliminate this by reducing this and this, from to. So be very specific and come up with some measurable metrics. And if you're using attribute data, trying to transform those data into more of continuous variable data. For example, if your goal is ensure that the pizza arrives to the customer warm, change that to say, ensure that the pizza is delivered within the 30 minutes time frame. See how you could basically track that and monitor that and make sure that your delivery guys are compliant with that. That's your specification limits that you set for your delivery guys. And the one way to go about that is using the CTQ flow down, right? As you could start with good quality pizza to the customer, then you could say temperature is your driver, taste, and maybe price, cost, so on and so forth. Okay, and then you can break these three buckets into CTQs and then into specifications. You see how the CTQ flow down helps set up your goals and objectives? So think about that. The scope, you can decide what's in the scope and what's out of scope. Don't get into the scope creep. Try to avoid getting into scope creep. Stay within the scope and work your way through the scope of the project. You know you have 8 weeks to complete this. You don't have 8 years, 5 months. Usually, as I mentioned, 3 to 6 months for a black belt project. Sometimes a year for a master black belt, depending on the project's entitlement. But here we have only 8 weeks, so make sure your scope is going to be, covering things that you will be working on. Don't get into scope creep. For example, if you're working on some manufacturing-related issues, don't try to get into finance issues or system issues, okay, or IT issues. The team has to be dedicated to that. And if you identify any action items that go beyond your scope, then that's going to be either phase 2 of the project or a different or a newer project. Another thing before I forget is I expect you to keep this document a lively document, meaning that you go back and make adjustments, changes, modifications. This is not engraved in rocks. And I expect you to go back to your problem statement and make modifications. No question about it. Even though we make the grading and we give you some feedback and inputs, we expect you to go back and make some adjustments. Anyway, the rest are some financials, and then you get into the team members and then completion dates. These are some examples for project charter. So read through this. There are more. Now, that is basically everything in that module resources. Those articles are important, and I expect you to read those along with the chapter. Okay? So, next thing I would like to cover with you is this team forum, define phase and project scope. So after you read that article for Project Charter, as you saw, and the chapter, you'll be able to determine what the scope of the project. Please, once you go to the group discussion forum, you see how this group is doing a fantastic job. Who is this group? Group B. Great participation, already on top of things. I can see the number of posts. I can see the number of participants. It's very important that you continue that pace. And if I click this, I already see the categories that I mentioned in the announcement page. Meeting times, how they're planning on communication, who's the team roster and role, the voting and file exchange, so on and so forth. This group is doing a fantastic job. I'm sure the others do as well. But I'm very pleased with the type of work that they've accomplished. Once they determine what the define phase, and I really expect from you to come up with a project charter and some of the tools that you've seen in the define phase along with the project scope, and put all of that together. In fact, let me pause something here very quick. And okay, assignments and rubric. And let's look at the homework assignments rubric for this week. That way you have an idea of what's required from you to accomplish. This is the rubric. In fact, I would like to call the final project rubric. All right, so let's pull this down. And for milestone 2, define phase and project scope, you'll see that you will submit project scope and overview and tools used in the define phase. Project scope and overview and tools used in define phase. Follow the format. And as you can see, the project scope should be this word count, and the overview of the define phase should be 1 to 2 pages. Okay? So we know what goes in the define phase and the tools that reside in the define phase. The CCQ flow down. What else? The voice of the customer. The project charter. And all of those are illustrated to you, as you see in the, learning modules for module 2. And it's been specifically listed to you the problem statement, the project scope and project goals, affinity diagram, CTQ, and so on and so forth. Okay? If you would like to include the ones that I mentioned around stakeholder analysis or SciPox, feel free to do so, but I would recommend to stick with just the ones mentioned to you in the define phase. Okay? Everything that's been covered, module 2 overview, and so on and so forth. In the module resources, you'll find more in that regard for your define phase. So I hope that's clear, and you can find this through the final project rubric. Now, finally, I would like to touch base on Chapter 6. And for Chapter 6, there's a lot of good information there. Again, I'll be posting this recording on the announcement page, and I will also put a summary for everything I mentioned. I would like for you to stick around if you would like to learn some of the concepts in this Chapter 6. And the Chapter 6, as I look at it right here, there is a project charter again that simplifies and explains and gives an example in page 246 around the project charter and all the elements of that project charter. You'll find slight variations in different project charters depending on the company you work for and their consulting group that they worked with to implement Six Sigma and incorporate Lean in their business. But regardless, project charters usually include the project scope, the business case, the team and owner, the key customers, the timeline, the problem statement, the goal statement, of course, the scope in and out. So these are the major elements, and also some financials in terms of hard and soft savings or project entitlement, and also the metrics, the primary metric and the secondary metric. And to be more specific, if you would like, go to minitab.com and you will find, let me show you, the software in minitab.com called Quality Companion. Products, this software here, Quality 3, you can get a free trial. I definitely recommend that you get a free trial, because once you try to set up a project charter in this software, what you will find is the key elements that are part of your project charter. And also, when you go and look up the define phase, you'll see the different tools that fall in the define phase. It's being laid out to you in a very good way, and it's from Minitab, so you know that it's a very reliable source that you can depend on. Once you go through the project charter on page 246, you get to the project decomposition or work breakdown structures. This project decomposition or work breakdown structures, you will see, a lot of different ways of doing this. There's the work breakdown structure. There's the tree diagram. There's the PDPC diagram. There's interrelationship diagram. There are multiple ways to break down a system into components, into subcomponents. This is the goal. That is the concept of Six Sigma. CTQ flow down does the exact same thing. It goes from a broad concept or a broad voice of the customer and breaks it down into small elements, which we call CTQs, or those Ys, and then we get into the X's, or the input variables, and then the specifications and so on and so forth. So think about that. Work breakdown structure is mainly to go from a system into a subsystem, into components, into subcomponents, and so on and so on, into processes, into steps. Does this ring a bell to you? This sounds like mapping a process or a process map. It does the exact same thing. It takes a system, breaks it into processes, and then steps. And each step could be broken down even further. Another piece is the sidewalk supplier input process output customers. You have a process, and then out of that process, you build the input to that process and the output to that process, the IPO. And the input variables are the X's, and the output variables are the Y's. And the process resides in the middle. And then you understand the suppliers that those input variables, and then you understand the customers to those output variables. That is the concept of SIPOC. So Pareto analysis is a prioritization tool. When you use it, it's to just prioritize where you will spend most of your resources and energy. You're going to focus on the vital few, the 20% of the drivers that contribute to 80% of the problem. Minitab can help you accomplish that easily. Okay? And there are so many ways to go about accomplishing that. Deliverables, it talks about the critical to quality metrics. Remember, CTQ axis, critical to quality, critical to safety, critical to delivery, critical to maintainability or maintenance. So CTX, you'll hear this term as well. Same concept, still uses the tree diagram, but also, and it breaks it down into those Ys for the project and then to the small X's. Defects per million opportunities in the sigma level. It's good to know the DPMO because that's how Six Sigma is measured. But one thing that I like from the textbook is on page 253, what it talks about when to be cautious on how to estimate the DPMO. When you have a single characteristic for a defect, then you're talking defective items instead of defects. And in that case, there's not much to worry about. But when you have DPMO estimates for anything beyond this characteristic, it should be treated with caution at the least. And there is an example in that first paragraph in page 253 that explains just that. But remember how to calculate DPMO once you understand the defects and the number of critical characteristics and the number of items multiplied by 10 exponential 6. Then the sigma level can be generated from there. The throughput yield, very important. There's throughput yield, there's rolled throughput yield, and normalized yield. These are ways to understand how you yield in your process. And this is one key metric that reflects the number of conforming to quality versus those that are non-conforming to quality and what that percentage is. If you're looking at one process, you're going to use throughput yield as in the case, and you take a defects per unit, which is equal to the number of units divided by the number of items, and then the throughput yield is 1 minus DPU. That's simple. Okay? So throughput yield is the opposite of defect percentage. That's why we use 1 minus. But when you talk about multiple processes, let's say this process generates 82% throughput yield, meaning good quality product, and the next one generates 89%. So for that department, what is the raw throughput yield? You multiply the different processes together. Or if you have a production line with multiple machines, let's say you have a flow layout process with multiple machines, a packaging machine, a sealer machine, that's a denester machine, whatever. In that case, each machine will have a throughput yield. A raw throughput yield will be basically that whole line. How is the yield for that line? The normalized yield is the average, just like the average. Okay? Rather than multiplying, you're pretty much finding the square root, such and such and such. Just think about it as the average. We talked about critical to schedule. Same concept. In this concept here, we have multiple factors. We have the cycle time, process cycle efficiency, process lead time, and velocity. So just to kind of explain this very quick, the cycle time is what? A lead time can consist of multiple cycle times. Cycle time for the machine, cycle time for the operator. And think about it, from the time the machine does all its operations to the time it starts the next operation. Okay? So if the machine does task A, B, C, D on a certain product, then the next time it's going to start task A, it starts a new cycle. We call it machine cycle time. The operator is the same thing. If they're packaging a box, between the time they package the first box to the time they package the next box, that's called cycle time. For the process cycle efficiency, it's different. It takes the value added divided by the total cycle time. That is the difference. Process cycle efficiency is taking the value added time divided by the total cycle time. So, with that being said, it's very important that you understand the value added versus the non-value added. That's going to lead you towards the lean philosophy. The process lead time is very important in value stream mapping. It's very important in understanding manufacturing lead time. It's very important to understand how long that product takes to be manufactured, or how long it takes from when the customer submits the order to the customer receives the order. You see how that long lead time. When you order a computer from Dell, to the moment you receive that computer at your door until it's delivered, that is the lead time. And it can vary. You can have a lead time from door to door within a manufacturing facility, or you can have an extended lead time that tends to encompass your suppliers and your customers and your IT systems from the transactional piece of it. The velocity is another critical to schedule piece, which looks at the number of steps that are value added versus the total steps. And it divides them and it tells you how your velocity is. Overall equipment effectiveness, which is the OEE. I wonder how many of you used this concept before. But it's a great concept, and this OEE takes three key criteria into account. It takes the availability times performance or the line speed times quality. So it basically reflects how the business is doing from these three key components into one metric. So in page 260, it explains exactly just that. Then you're going to get into some financials when we talk about critical to cost metrics, variable costs, fixed costs, break-even points. We're not going to get into this, otherwise we'll spend all day. The net present value, the future present value. But this, let me tell you, this is more on elaborating on key concepts of these costs and schedule and so on and so forth. But it will help you kind of understand the key components within your project charter. But does it really fall within your define phase? It kind of does. It kind of, maybe goes far and beyond. But it's good to understand these key components because it's part of the CTQ and CTQ is part of the define phase, whether that makes sense or not. Also, your project charter tends to talk about the hard savings and soft savings. It's good to understand the return on investment, the net present value, the internal rate of return, all these things once you justify them for the projects or using your, doing your project selection. And then the top level process definition, you have the process maps. And this is a great piece of the puzzle. Process mapping is very critical. You have to always use process mapping to understand your whole process, and for you to be able to understand the inputs and outputs on each step of that process. And besides, you have it visually in front of you where you could analyze each step of that process. So assembling the team is the last piece. That's self-explanatory. And that's where I mentioned the stakeholder management and identification. That's stakeholder analysis. That tends to help you understand how you're going to identify your team, which eventually will help you complete your project charter. So your project charter looks at the purpose, the impact, the success criteria, the boundaries, which is your project scope, what processes are we addressing, what is in and not within scope, and then the main initiatives, and then who and what, the team selection and responsibilities. I suggest that you build a project charter based on the exact, based on the descriptions and requirements that you have for activity of 2.2. And 1 to 2 pages is enough for your defined phase, and the project scope should be 75 to 125 words in length. Regardless of how you want to present this, the key is I want to see something that builds on top of what you've previously completed for week 1, which is the problem statement. So you want to stay in accordance to your problem statement and don't deviate from the problem statement. Don't get a goal statement that has nothing to do with your problem statement. And if you need to fine-tune or correct or modify anything, then feel free to do so. I hope that this explains and elaborates on the requirements for this week, and you feel pretty good going about submitting your discussion, working with the team, and doing the quiz, and doing the self-assessment, and reading Chapter 6 and the articles provided here within. That's all I have for today. I hope you have a great week. You'll soon enough to receive the grades for your problem statements and for your discussions for last week. And the only thing different this week from last week is that you have a quiz due at the end of the week. So good luck to you, and hope you enjoy this session. And if you do, please submit some comments and feedback on the general questions area of the discussion board. Okay? You all have a great day. Take care. And I look forward to hear from you and see your excellent work and great participation on the discussion board. You have to continue, particularly the team forums. Some of you only have like 11, 12 posts. That's not enough. So please continue to participate, continue to contribute, and you've seen how Group B is doing. That's the benchmark. Best of luck to you.